In the last video you watched, we took an equation written to solve for the perimeter of a rectangle. We had P, the perimeter, is equal to, we have two lengths plus two widths. Now what happened is we rearranged this equation so that we could isolate this variable L, so that we could calculate for the length of one side of the rectangle. And we did this and got L is equal to the perimeter minus two widths, all divided by 2. Okay, so what we call this process, where you take an equation, our equation 1 here, for one variable, solving for P, and we rearrange it to solve for a different variable. In this case, we rearranged it to solve for L in a new equation. We call this process transposing an equation. Now this word essentially means to rearrange the equation to have a different variable isolated. In this case, we transposed the equation for the perimeter P to isolate the variable L for length instead. Now this isn't a matter of simply rearranging the letters in the equation in any way that we feel. Transposing an equation implies that we do this rearranging in a way that the mathematical relationship between the variables is maintained throughout the process. Essentially, we are always trying to maintain the balance of the equation by making sure whatever we do on one side of the equation, we do to the other. So as we balanced the first equation by having, P be the same as 2L plus 2W, we also achieve balance in the second equation, where we have L is equal to P minus 2W all over 2. Now, we have a lot of strategies for how we do this, and I'm going to show you a few tools that we use to make sure that we're always maintaining balance in the process of transposing an equation. And that's what we're going to do in the next videos.